Who was here in the previous talk? Okay, a few people. Who's using functional programming style with Scala? All right, good enough. So this talk is about a framework or collection of libraries, basically, that helps you do functional programming. And it removes a lot of the boilerplate that Adam described in the previous talk associated with free monads and tagless and all of these kinds of styles. So I'm Raúl, 47 Degrees. We do consulting for Scala development. We're mostly a functional programming consultancy. And that's why we built Freestyle, which is currently an open source project composed of many libraries that touch different parts of the, Cassandra, Kafka, RPC, free monads, and so on. So the reason why we built this library is because we were finding that getting into functional programming is kind of hard, and there's several reasons why that can happen to you based on your background. Maybe you have like no category theory knowledge or no math background. You're used to different kinds of styles of programming, like object-oriented programming, which also is supported in Scala. And also, we have to recognize that at this point in time, there's not a lot of good documentation for actually building functional programming related applications in Scala. And it's a very, very rapid changing ecosystem. I don't know if you guys are following CATS or Scala set, but basically from CATS, from where we started now to almost 1.0, there has been a lot of changes. All are backward incompatible, so you have to keep up, and it's kind of something that is still getting brewed in the Scala ecosystem. And the other problem is Scala's encoding. Being a hybrid between object-oriented and functional programming, we find in many cases that some of the techniques we use in functional programming in Scala take a lot of boilerplate. And an example of that could be if you were here in the previous talk and you saw how you combine free monads with coproducts and so on. That's a lot of boilerplate to do something that is just combining algebras. And the other reason is there's not really a lot of good examples out there that can help you, like cookbook style. Like how do I build a huge system in a purely functional way? So we started this library and we had a few goals in mind. It had to be approachable to people that were getting started with Scala as well, not just people that are already acquainted with functional programming. It had to be stack safe, because that's important in functional programming. We are calling a bunch of different small functions, and then eventually if you're not careful and you're using data types or abstractions that are not stack safe, that can result in a stack overflow. And that's why Adam was also making emphasis on free versus tagless. And we also provided a bunch of integrations with the 16 Scala libraries, like Doobie, Sleek, a bunch of those. So what we wanted Freestyle to become was a library that it's helping people, and it's actually being used now by many people in production. We have a Gitter channel. You guys can swing by anytime you want. And we want it to be very pragmatic. So it's not about like learning really deep about types or functional programming before you can become productive using it. So that was our main goal. So what you're going to see in this talk is like the programming style you follow with Freestyle, a few of the annotation macros that actually help you reduce and eliminate all of that boilerplate, the effects library. We're going to like take a quick look at a few features, and then some of the optimizations that make Freestyle about 10 times faster than free in CATS or Scala set, because we have optimizations at the actual runtime that make it more suitable for production applications. And finally, we're going to look at our approach on how to build microservices that are based on RPC. So let me see if I can make this a little bit bigger. Can you guys see this fine? Is that good? All right. So basically, in Freestyle, to make it easier for people when they join, instead of telling you have to build this ADT, you have to use these coproducts, compose them in this way, and do all of this kind of boilerplate to actually work with free monads, we give you a simple interface implementation style approach, much in the way as you will find in the Tagless style. So this is actually a free monad algebra where there's two operations defined. In a little bit, we'll look at what fs means. But basically, this allows you to abstract away the return type of your operations. And what that effectively means is that in your programs, you can write programs that are completely decoupled from declaration, from their interpretation. So if you were writing a library, you could write a library describing all the operations that it does, and you don't need to say, okay, this is going to go to future, or my users need to use task or IO or whatever. Your users can use whatever they want. So how do we make the actual implementation? We just provide an implementation of that handler extension of that interface. This is actually done with Scala meta macros in Macro Paradise. So when you annotate that trait, Freestyle will generate all of that boilerplate that Adam was mentioning about the ADT, the coproducts, the inject, and all of that. In this particular case, the handler doesn't do anything interesting. It just proves that you're not coupled to an actual data type because you're using future here. But where you're using future, you could have been using option or anything else that you wanted. So the logic is completely separated from the actual runtime. So basically, this is a little bit what the macro would do for you. If you annotate an interface that looks like this, if you were to do this by hand, it would look actually like this. So you would have to create an ADT. You had to create a smart constructors that have the inject instances, do the manual boilerplate of lifting your values to the actual data type, the free. And then you will have to provide a bunch of implicits for those things to actually work when you want to use those algebras elsewhere in your application. So Freestyle provides that automatically for you. It's actually a lot longer than that because the typefs, if you know about, are you guys acquainted with monads on how they work? Raise your hand. Okay, more or less. So monads are used to express sequentially. So you have a set of operations, they are one chaining one after another, meaning the second operation always depends on the value of the first one, or the order matters. So the effect in which operations are executed, they have to be in that order. So in that case, we use monads. But if we want to use concurrent programming, meaning parallelism, we have to treat operations independently. Why? Because we have to run them at the same time. Therefore, one cannot depend on the result of the previous one. So fs is actually an alias for free applicative of f, which means that freestyle programs can be parallelizable. So at any point in the program, you can say this set of instructions are actual parallel instructions. And whenever they're done, the result is going to join back into the monadic flow. So with that particular concept, you can always describe a program as a sequential line, which forks at some point into parallel computations, and then it joins back into the sequential line. And with that, you describe most programs, or all of them. So we not only do reduction of the boilerplate at the algebra level, which we saw in the previous talk, but we also do when we compose algebra. So Adam mentioned that we use Coproducts for that. So Freestyle is able to generate all of this boilerplate with otherwise you would have to write manually, where you create a coproduct of one algebra and the other algebra. Then if you want a third algebra, you need to use the previous coproduct on the right. And then if you want a fourth, you need to use the previous coproduct. So all of that is super tedious in Scala. And it's also very inefficient to evaluate. Because if you think about this, you're creating like a deep, nested, kind of like a list, where if you want to interpret an operation, say, at that point, the constant time evaluation is not constant because you have to traverse the list to that point, then evaluate. So the more algebras you have with free monads and your manual encoding, the slower and more inefficient your program is going to be. So Freestyle solves that problem, and we're going to see in a second how we do that. So how does it feel programming with Freestyle? You declare your algebras. You can group them into modules, which is what we just saw here. So here is a module. The only thing you need to do is create a trait, and then place your algebras as abstract methods. And then Freestyle automatically implicitly brings them into that trait. So it feels like dependency injection in OOP, like if you've worked with, I don't know, Spring or other frameworks and you had the inject or auto wire. So the same concept, but it's done automatically via implicit. So it's a compile time verification. So there's no way to screw up at runtime when you wire your dependencies. By the way, if you guys have any questions, feel free to interrupt at any time, and then we can clarify any concepts. So you can write many algebras, you can group them into modules, and then you can compose your programs. And once you compose your programs, you can provide implicit evidence that you've written those handlers, which is actually how the program is going to run. But that's separated from the program declaration. And this effectively empowers the style, which we've heard before. You have to push the effects to the side. In pure functional programming, there's a single point of execution where you do unsafe perform IO or unsafe whatever run, which is where the entire program unfolds and then everything is run. But the rest of the application remains purely functional at all layers. So you can declare algebras like we saw before, just put in a trait and add in a couple of operations where you describe the return type. And if for whatever reason you don't want to optimize your program in terms of using free monads like we saw in the previous talk, you may want to choose a tagless style. And our actual encoding and implementation for both free and tagless are exactly the same, in the sense of both free programs and tagless programs are declared in a tagless style, which is using traits. You don't need to use ADTs or case classes or any of that. So just say my program, I want this part of my program to be tagless. That won't create the ADT, that will use the tagless approach. And I want this part to be free because I want to use it as a value, or I want to further optimize the program, or I want to have composable interpreters, which is harder in tagless. So you can pick and choose whatever style fits best based on your domain program. So then once you have your programs, if you wanted, you could compose them into modules like we said before. And if you realize, like, now what we're doing is like describing an application where the top thing is your application, and then it's like a tree. Branches start falling down. So imagine the different layers. Persistence, view, whatever. It's one of the layers. Those are modules. They keep like layering down until at the end, like the most bottom part of the tree is the actual algebras, which is the primitive operations that actually conform your application or program or library. If we noticed before in this previous slide, we said that the tagless, that we could compose free and tagless. That is actually true. We can compose free and tagless, and Freestyles gives you automatically a stack-safe representation of any tagless program, which you can mix into any free program as well. Basically just saying, give me the tagless, the stack-safe representation. And then once you have your dependencies wired, for example, here we're using validation, another algebra called interact. We are using an effect algebra to handle errors, persistence. You can create programs in the same way you did before. If you've noticed, we don't have the f_career in our algebras, but you can also use them that way, because the macro itself, when it expands, it actually uses a higher kind f, which is going to be the final value of your program. But if you define your programs inside modules, or you stay within the boundaries of Freestyle's management, then you don't need to worry about carrying the f and parameterizing the entire program, which is a lot easier for people that are getting started, not understanding what higher kinds are or how they are important in terms of parameterization. And then if you're not in the context of Freestyle, then you can use your f and then just require implicitly any of the services of algebras you've defined at any point, just like saying, hey, give it to me here, I'm going to use it. And just works. Because Freestyles provides implicit factories for all of the algebras that you create, so you can require them implicitly anywhere in your application. So this is what an actual interpreter or handler will look like. In this particular case, we're saying that our program that we've looked at before, it's going to be interpreted to this target. Why? Because we're using purely functional state. We have error effect capturing. We are keeping the state in this list of string, and this is our program value. So the only thing we need to do is just create a new instance of a handler for the algebra, for each one of the individual algebras, where we provide an implementation of how we actually go from this parameter to this target. And you can have as many implementations as you want. You can use futures or IO or task in production, and you can use option either in test, if you don't want to like rely on a concurrent runtime in your test for whatever reason, because what you're testing, the program, the declaration itself, is agnostic to the actual interpretation that it's going to. How does this all come together? So we have two things to keep in mind. One thing is like if you create your interpreters like here, then you will have to bring them into scope because those will be implicit. So the evidence of those being implicit into scope, it's going to give you a way to run your programs. If you're using in this case, we're using a state T from cats and some effects that rely on cats. So you have to bring cats implicit as well as you would do in any other Scala application. And then finally, here we had a module called application that had a bunch of algebras and a program. So if you notice here, then we can use the actual module, the Toplevel OOP, which is an alias that is the entire coproduct of all the algebras that have ever been used in your application automatically, expanded for you there. And we can then run our program to the target we provided, which can be this target or can be any other target that is not IO or task or whatever. So we also have an effects library. The effects library, have you guys heard the term monad transformers? All right. Have you used monad transformers before? Okay, a few. So if monad transformer come handy in the case when you're, for example, calling a server and you're using future from Scala, right? And the server, you're asking for an account. The account is going to potentially be not there. So you represent that as a future option of account. And how do you get to the actual option? Then you start doing a lot of type fiddling, right? Because you have to flap map through the future, ask the option if it's empty or not, or fall over the option. Then you have to leave the final value back to the stack. So that's potentially very tedious, and that's the problem that monad transformers solve. You can use in that case option T. But in Freestyle, it's even easier because our programs are reified. We can apply also algebras that are acting as monad transformers and eliminate the need to nest everything or wrap everything into option T. So we have the same for that we just discussed for option. We have for error, either, reader, writer, all of these different effects, they can be used through the effects library inside Freestyle programs. And they look something like this. For example, in the case of either, have you looked at either T or seen either T in the wild before? Okay, so if you had a future of either of something, then you would use either T to flatten through the value that you actually care about. In this particular case here, imagine that we are using an error, right? So similar concept. We have an exception, and then we just want to raise the exception into the context of the monad. We don't need to create an either or create any kind of complex thing. As long as the target interpretation supports the abstraction of monad error, which provides ways to raise errors into the monad context, then we can simply say, call the error M algebra, which we can import implicitly in any way, and then you say error, and then send in the exception. This will actually circuit the program. And just to illustrate that, it doesn't really, you don't need to be coupled to data types. You can just work with the actual behaviors and abstractions. We are interpreting this same program to both either and IO. And if you notice, when we interpret to I/O, we then call attempt, and then we call unsafe run sync, because those are methods on I/O. But it's the same program. And this is actually not, I didn't make it up from this is actually type checked. So the presentation uses std to show you that this code compiles and runs as is. So take a program, run it anywhere you want. Are you in production? Run it to I/O. Are you in test and you just want it to blow up if there is an exception or something, or capture the left value? Run it to an either. Anything that can provide a monad error instance, which CATS provides monad error instances for all the data types in Scala that do support them. Any questions so far?
So the error M effect also has a method for recovering errors?
Yes, it has. It's basically a reification of the monad error interface in the context of free algebras. So basically, when you're working with free monads or programs in this way, you can reify any concern up one level, and then just pass that responsibility to the interpretation, that the actual type that you're going to run into, it's able to support that capability. For example, we couldn't run this to option. Why? Because option cannot have a monad error instance for throwable. Why? Because the none or some, there's no way to put there an exception. If we put it in none, we lose type information. We don't know what type of exception it is. So the data type itself, the way you write your program, tells you what you can run it into. Same deal with option. If you're using option T, if we ever encounter an optional value, we can just pass it through the option effect. And now we can run our program to any data type that is actually able to provide a functor empty instance, or monad filter, how it was called before. So option is one case, list is another case. Why? Because list is able to say my empty value is nil, and option is able to say my empty value is none. And if you can define an instance for any of those data types, then you can run your program to that data type. So optimizations. Freestyle and the whole coproduct thing that I mentioned, this is based on a paper by Swerstra called Datatypes a la carte. I recommend you guys, if you are not acquainted with this paper, it's very interesting. It shows you how you can actually combine different monads and algebras that are parameterized in different ways as a single program using coproducts. And what we've done is actually we implemented the free inject coproduct pattern, but we also optimize it for the JVM. So we have a library called Iota, which is for fast coproducts and fast higher order function case. And Iota, among other things, keeps, for example, in the case of coproducts, an index array of all of your algebras when you summon the coproduct. And what does that mean for you at the runtime? It means that the blue area is Iota, so constant time evaluation, no matter where the number of algebras increases. So this is an application that has 100 services. So imagine your huge system, 100 services, all decoupled. Iota offers you constant time evaluation and no degradation of the runtime performance. Whereas if you were to do this with either K or coproduct or any of the implementations on the CATS or Scala set libraries that are based on left and right, then because of that left and right pairing and kind of nesting down on a list, then you end up paying the performance penalty and subsequent degradation of your program as the number of algebras increases. So it's very important if you're working with free monads or any kind of reification style and you're combining, look at the coproduct evaluation, because the number of algebras may affect how your application performs. Another optimization we do is we optimize the function K. So if you guys noticed in the previous talk when we were taking an ADT and going from my ADT or my algebra to future or to whatever, and we were basically saying my operation is going to be interpreted or translated into this, that uses pattern matching in Scala. So what happens with pattern matching? As the number of cases of pattern matching increases, then the runtime overhead also increases because you're calling unapply, potentially allocating new instances every time you do that, and the bigger the pattern match expression becomes, the slower your program is going to evaluate. So Iota provides a function K implementation that we use in Freestyle that is actually also based on an indexed array. So we can index all of your algebras, and then when you tell me I want to run this particular operation, I change the pattern matching for a switch on the JVM. So the switch goes in constant time evaluation on an integer value to the right algebra, and it runs your operation. So you reduce a lot of the overhead associated with free monads, and what people always tell you is like, there's too many instances, or allocation is a problem. Well, it's a problem depending on how you use them, right? It might not be a problem because, people, do you use a Slick, or have you used a Slick before, or Doobie? All of those are based on free monads. More optimization. We were told if you use a Tagless program, you cannot run it in a stack-safe way if the target monad that it runs to is non-stack safe. And that is true for option, for example. But we have actually a way to do that. So if you define all of your interpreters, imagine you're targeting option, and then you realize, shit, Stack Overflow when I didn't expect it. How do I change this? Now, you have two options. You can change all of your interpreters to be free of option, or trampoline option, or do something on the interpreter that actually leaves the value and removes that problem with the stack safety. Or in this case, we just wrap them with stack safe option. And what we're doing is automatically, every time we run one of the operations, we lift that operation into the context of free of option, so that you can have unsafe interpreters, unsafe programs that are actually stack safe for free. Have a bunch of integrations for the different Scala libraries, Doobie, FS2, Slick, HTTP, Play, in the way that if you have a program that is completely pure and declared, you can just put it in a play endpoint or an HTTP route handler, and then we do the work for you of running it at the edge and doing the right thing so that you don't have to worry about performing effects. So you can enforce patterns on your teams and applications that people are exclusively returning and working in the context of purely functional definitions. So we have a bunch of those. And actually it's getting a lot easier because everyone is kind of coalescing into Cat's effect. So that's removing a lot of the integrations that we're having, because now we can just target effects in Cat's effect, and then we get for free money stacks, Cat's.io, and so on. And we have some standalone libraries. So we are building this also to be used in the enterprise. And because of that, we are actually building libraries that are wrapping purely functional access to Kafka, to Cassandra, and to gRPC. This is actually a work in progress, so they're usable already, but they're not to the point where we want to be yet. So take this with a hint of salt. So we have consumer, producer, and then we're working right now on the streaming algebras for Kafka. For Cassandra, we have type-safe query interpolators that are actually validated at compile time against schemas, access to the low-level Cassandra APIs, automatic encoding in different formats, and RPC. So we're taking all of these libraries together, and then we're making a reference kind of like micro-implementation of what a purely functional microservice will look like. And we're doing that in FreeS microservices. So if you guys go to FreeS.io, you're going to see a bunch of these projects there and some examples and a bunch of stuff. So what is an actual service like RPC service looks like with Freestyle? So in this particular case, we just have a bunch of case classes, right? These are the things that are going to go through the wire. You just annotate them with message, and we create proto-buffer automatic encoders and decoders for those. So you don't need to worry about typing the actual proto implementation, though you can if you want. So this is a Scala first approach that I'm showing you here, but you can go the other way around. Once we have all of our case classes that we're going to send through the wire, the only thing we need to do is define an algebra and expose that algebra as a service. So the same way you've done all of the other algebras that we've seen before, where you use like define abstract operations that are free of interpretations, you do the same for microservices. Expose your algebra as a service, And then we support streaming as well. So because RPC supports request streaming, response streaming, and bidirectional streaming, so do we. Our implementation currently is based on Monix observable, but you can basically connect a client to this endpoint and then stream back and forth messages as you wish with no boilerplate associated. So what it gives you for free is a gRPC server. So all of the boilerplate that you will have to write to actually connect to gRPC to expose your Scala application in a RPC context. We give you for free the client as well. So when you define that algebra, the route guide service, there is a route guide service .client that you get. So you don't need to write the encoders and the boilerplate to do the connection to the server and so on. It's all done for you. And then we give you protofiles. So if you are interoperating with other languages, such as, I don't know, maybe in your organization there is people using Java and Scala and Python and PHP and whatever it is, you can just run SBT ProtoGen, and then protofiles will be generated out of your services, which anyone can use to generate further clients in other languages and connect them to your actual service. This is a work in progress in the SignFace, so this is actually, you're not going to see any code, but basically what we're doing in the microservice area is that once you have an actual RPC service, you can also directly subscribe to topics in a PubSub style kind of abstraction, where Kafka is the default implementation. So you'll be able to say, I want to subscribe to a type-safe topic, which it's in my ADD, so there's no error using the strings back and forth to use with Kafka. And then I'm listening here to this type of records. In the same way, when you're writing the implementation of your service, you can get a hold of producers for your values, per system to write to Cassandra and so on, automatically without having to configure anything manually, like building the whole scaffolding of this boilerplate. And ultimately, we're working in an ops center for freestyle microservices. It's not meant to replace New Relic or any of the DevOps tools that you guys use in your company. It's more of a way for you to, if you deploy this in a cluster, the microservices actually have automatic endpoints with health check and monitoring and so on. And they will, and you can lift up an ops center in another instance. This will connect to your services and give you a quick view of the health of your different nodes, which services are deployed there, what technologies may be using inside, and some of the important metrics as to transactions per second, things like that. So I want to say that Freestyle is not a replacement for CATS, it's not a replacement for Scala set. It's actually a higher kind of like level library to get things done with those libraries, with purely functional programming. So it helps you reduce a lot of the boilerplate. And it's been inspired in a bunch of different libraries, not just CATS and Scala set, but also Fetch, which is a part of Haxel we have. Simulacrum, so if you use a type class in CATS with the add type class, that's actually Simulacrum. And the same way they eliminate the boilerplate of doing type classes in Scala, we are eliminating the boilerplate of doing tagless and free algebras in Scala. And it's not just me doing crazy stuff. So there is a bunch of people working on this project from different parts of the world. Many of them are 47 Degrees employees. Some others are just community members that are using it. So I want to thank them for the hard work and making it happen. We are now in 0.41. So we are still in design and iteration mode. And that is all I have. If you guys have any questions, I'll be happy to answer any questions. Questions?
Regarding performance optimizations,
yes.
I'm not an expert on free modems and stuff, but I understand that deeply
Yes.
left associated, or right? I don't remember.
Yeah.
That's Freestyle to do with that.
Yes. So that's actually this part. So if you notice here, this is basically the issue, right? So you have, in this particular case, if you have a coproduct, in this case, cat's data coproduct, as you increase the number of algebras to the right, so this is a benchmark with one algebra, with two, with three, with four. As they're increasing, that is actually making the coproduct tree deeply nested.
I was more thinking of the program tree, where if it's leaning on one side more than
Okay,
the other,
yeah.
it's more costly to evaluate, I think.
In the program tree, that particular optimization is already embedded into the actual free data type from cats and Scala set. It wasn't that way before, but I believe probably like a year ago or so, that changed. They introduced new machinery that actually removes that issue. Any other questions? Well, thank you.